Hi there, and welcome to this part 2 of how you can instance and offset an animated FBX. So we've came up with this alembic recorder, and let's have a look how this is actually looking when we render it out. So I'm gonna make some room for the render section. Refer it to the null 1 SOP. Close it with a null, Alt N, shortcut, geometry component. I'm going to split my window, open up the geometry viewer. So this is our geometry. Put it in wireframe for a second so we can see it a bit better. Let's start with a material, PBR. I already have a bunch of color maps I can use, so just look for them, drag them in. So a normal map, emission, the base color, specular, roughness. I'm going to generate a metallic map as well, because there isn't anything metallic in here. I just take a constant and make it all black. Let's call this one metallic. Okay. This PBR material has an output shader button, and if you press this one, you're going to export this material into GLSL format. But before you do that, it's very convenient if you already hook up the maps at the right position, so it will calculate that into the shader format as well. So drag everything in. Roughness, normal, and the emissive. So if we drag that one material up here, select material, let's see how it actually looks. It's a bit dark. Let's set up a render format, camera, render. We need some kind of lighting. We leave that error for now. Let's see, it's starting to show up. I'm gonna move the camera a little bit. A bit closer. Change the pivot. If you set it to the minus value of the transform, you make sure that if you rotate, the geometry stays in the middle, no matter where you transform it to, so that's quite convenient. Let's see if we crank up the dimmer. Just copy this one, set it to a different position. This one was at 10, 0. Let's put this one at 5. And this one, it's -5. Okay, we'll just leave it now. It's good for now. Okay. So now we've set up the PBR material. Let's hit the output button. Leave everything at default. Press OK. We don't need that one anymore, so delete it. And drag this one over. So now it actually looks a bit better in the geometry viewer, so that's convenient. Switch this one off for CPU sake. Okay. So let's have a look if we animate this alembic. Set it to constant mode. You can animate it. And you see that the frames are dropping quite drastically. So this is not something we want. But the upside is that it's working currently. So remember that we have recorded the displacement of every point in a texture. So now we would like to have this information. I'm going to record it again. Let's see, we had a custom clear it record. So, okay, that's it. So there it is. So we've recorded the displacement of every point in space of this dense geometry. And we would like to have this information into the shader. So there are a couple of things we need in order to let the shader recognize this kind of information. And you do that by declaring a so-called uniform. And how I approach a uniform, it's basically a gateway from network space into GLSL space. So if you would like to have information from out of your network into GLSL land, you do that by declaring a uniform. So what do we need? We need this 3D texture, of course. So go to your shader. It's a sampler. It's a texture, so it's called a sampler in GLSL space. Add another one. We call this one sampler point data. And it's the null 3. So you see that immediately there comes a dotted line. So this texture is connected by declaring a uniform. But we have to do that in the text as well. So this is the vertex stage. We'll just start from above. Uniform. Sampler 3D. It's a sampler 3D because we have X and Y and also in time. So we have 3 dimensions. Let's call it like that. Sampler 3D, and it was called as point data. Close it up. Hopefully it's not too small. Okay. I think I'm going to split this one as well so I can look at my GLSL info. Let's see that, drag it in, open, so I can see if I bump into errors. So we're all good now. Let's see, okay, so we have our sampler 3D point data in here. A couple of other things we need is, we need some kind of index for every point in this geometry. And that's something that's not generated by default, so we have to generate it ourselves. And we can do that by creating that attribute by using a point sop. Let's see, custom attribute. We call it point number. Let's see. We can leave it at float. It's only one value, me.input.point.index. Okay, so if you take a look at these attributes, we have the n normal information and the UVs. Put this point attribute in between, and now we have an extra one, the point number. So we don't have to declare a uniform in here, we can just write it down in here immediately. Let's see, in float point num. Still no errors, so we're good to go. Okay, so we have our point index number. What else do we need? We're going to instance this geometry. So I'm just going to set up a simple instancing section. Set it to ramp. Let's see the length, how much. Let's start with 20. Close it with a null. Let's go to the instancing tab. Switch it on. Translate. Let's change the name of this TX. It's a bit close to each other. Let's crank the range a bit up. Okay. The convenient thing about using instances in GLSL is that Touchdesigner already declares a function how you can work with instances. In the vertex, it's already declared. It's called, I'm just gonna put in a comment in here. It's called TD instance ID. Still no errors. Okay. So we've got our point number index into GLSL. We've got our sampler 3D, the displacement of all the points. So now we have to somehow connect the point index to the displacement of the point index in here. We've got an instance ID in here, and we also need some kind of playback. So a playback which scrubs through this texture 3D. You can approach this texture 3D like you might have drawn this comic book where you can just flip through it. And you have drawn all these different poses of some kind of running character, and if you scrub through it, you create the illusion that it's actually moving. And that's basically how this 3D texture works. So you have all your different poses of the character, and you can flip through it. And that's basically your X, Y, and then you basically scrub through it into the Z axis. I'm not sure if that makes sense, but just remember that flipbook, and then it will probably makes a bit more sense. So we need some kind of playback for that Z axis in time. And we're just going to use a simple LFO. Set it to ramp, because it has to start over again when it hits 1. Put a math in between. And we had the range 34. Let's see. I want round numbers. Align, no. Integer. Set it to floor for now, yeah. Close it with null. We have to put it in here. Let's see, into the vector stage. Let's call it uniform playback. Drag that one in. So the dotted line again. Let's get in here. Uniform float U playback. Yep, still no errors. Okay. So we have our playback instance texture. I think you can start writing into the main stage of the shader. Let's leave that comment there for now. Okay, let's get our point index number into the main stage first. So we're going to declare a new variable. It's a float. We call it point index, and it gets its information from the point number. Close it. Yes, no errors. Now we need that number, or we're going to use that number and look up every point into this first texture. There are 34 textures in here. We're just going to look at the first one. And you can extract information from a texture into a GLSL by using a function that's called Textual Fetch. So I'm just going to fill in a comment first. Textual Fetch. Let's see. We're using a 3D sampler, so we need 3 values. We're first going to write in the texture where it actually needs to look at. That's the point data, so point data. Then there comes an IVEC3, a vector 3. That's what I meant with 3 numbers. Don't try to interpret vectors in a linear algebra sense, because then it's going to make your life much more difficult. Just approach a vector 3 as a container which holds 3 values. And this texture 3D holds 3 values. We have an X, a Y, and a Z. So I'm just going to fill in X, Y, Z, close it. And it also needs the last value. It's technical stuff. Just fill in the 0. That's it. Okay, close it, but it's a comment, so we're not going to get errors anyway. Yeah. Okay. The X, the Y, and the Z. The Z value is actually quite simple because that is the playback through the flip book. And that's something we've already declared, the U playback. So I'm just going to declare another variable. Let's call it offset float. Offset, and it's looking at U playback. Close it. Still no errors. Okay. So the Z, going to fill in offset. Okay. So that's quite simple. Now comes the tricky part. We have to connect the point number to the different pixels in this texture. So if you have this pixel here right in the left corner, 0.0, the next one 0.1, 0.2, 0.3, etc. And if you go one level up, you have 1.0, 1.1, 1.2. So it's basically a coordinate system with coordinate numbers. And we somehow need to connect these point numbers into a coordinate space. And there are a couple of tricks we can do. The first thing we need is that we need to connect the point number that start with the X. So the X is going from left to right. So it's incrementing up into the width of this texture. This one, actually. And that's 178 wide. So it starts at 0, 1, 0.1, 0.2, 0.3, all up to 0.178. And then it goes up. It's 1.0 up until 1.178, and then 2.0, 2.1, 2.3, 2.178. Well, you probably get the point now. So we need this width of this texture also into the shader. So we do that in the vector stage as well. Let's call this U texture width. Just let's see, chop to 1, up, chop to 1 width. Okay. Put it in here as well. Uniform. It's probably float as well, I'm not sure, but we'll see if it gives an error or not. U text width, close it. Still no errors. So let's get back at our Textual Fetch function. We have our offset already in here, X and Y. Just going to put in another comment. Let's see, let's call it float as well. We call it vertex x is, well, let's look at the u text width first, close it, and then we need one for the y as well. Vertex y is u text width. Okay, no errors because we used comments. We're going to remove that one. Still no errors, but probably if I remove these, yeah, okay. Let's comment it again. Okay, we have our vertex x variable and our vertex y variable. The vertex x is incrementing from 0 to 178, and if it moves one level up, it's going to start from 0 up until 178 again, and it's going to repeat itself. So the y is incrementing after one cycle of 178 pixels, then it goes up again. So there are a couple of techniques we're going to use. The first one, it's a bit annoying to understand how it works. It's called modulo. Imagine that we're living in a world where only round numbers are allowed. If you take the texture width, 178, and you divide it by the point number, let's say point number 100, 178 divided by 100 isn't going to give a round number. You might remember this from school. If you take a number, let's say 15, we're going to divide it by 10. This 10 is going to fit in here only once. So only once. 15 minus 10 is 5. So we have 1 and a 5. This is what they sometimes call the remainder. In Holland we used to call it rest. So it's basically what's left after 15 divided by 10. So it's 1 times 10, and you have left 5. So let's take another example. We take 16 divided by 5. This 5 fits in here 3 times. So we have 15 minus 1. So we have 3 rest, or remainder is 1. So, and this is what's called modulo. So when you see that with modulo, you can somehow create a coordinate system into GLSL. So the modulo is going to help us out by forming our x coordinate. I'll show you how that works. Let's see, it's the x. So modulo, we have the texture width and the point number. So point num divided by texture width. So if we start with point number 0 and we divide it with the texture width, the modulo gives us only 0. And if we go to point number 5, it gives us 5. If we go to point number 20, it gives us 20. But when we're going past 178, it sees that it's going to be divided by 178. That's the texture width. So it starts from 0 again. I'm going to clear that up with this again. So new layer. So if we're going past 178, let's say 200. So the point number is 200 divided by 178. Remember, ideal world, only round numbers, so it's going to fit in just once. 178. 200 minus that is 22. Yeah, so y is 1. This is the modulo 22. So the remainder. So what is left? X is 22. So hopefully that makes sense how modulo works. So we now have our x value. So for the y value, it's actually quite simple. We just use, let's see, I've declared a different variable for that. So point index, yeah. I think if I can uncomment that one, float. I'm going to comment it again, we'll look at it later. Vertex y, this one is actually quite simple. We just use the point index divided by the width. And since there are only round numbers allowed, I believe that this textual fetch function doesn't allow floats, only integers. That's what this IVEC3 is standing for. I'm not quite sure, but if you just divide the point index with the texture width, it's going to give a decimal number, but it's going to cut it off to the floor value. So if you're going below 178, it's just going to give you 0. If you're going past it, it's going to give you 1 point, yada yada, and it just stays at 1. So it's probably going to make a bit more sense if this function is actually working. So the x, we fill in the variable vertex x, vertex y. We have our offset. And now it's just fingers crossed. Let's see if this is actually working. Just uncomment everything. Now we have a couple of errors. Let's see, textual fetch. Now we're going to have to give this one a new variable as well. Textual fetch, let's see, let's give it a vector3 variable, because we have x, y, and z, 3 values. Let's call it the animation point data. Animation point data is textual fetch. Let's see. Oh, this has to be a capital F. Yeah. We have an implicit cast from vec4 to vec3. In line 35, sometimes if you declare a variable and you call it effect3, and it's actually looking at a function which uses effect4. That's what this error most of the times stand for. So if you put in here XYZ, you're basically saying that, okay, whatever kind of vec4, whatever you are, you're just going to use the values XYZ. So you're basically forcing that function, that vec4 function, into a vec3 by putting this point XYZ behind it. So you see that this immediately moved out of the way, but we still have this modulo error. I think that I already see what's happening here. I put this divide sign in here, but this modulo function already know that it needs two values and it's going to divide it. So I don't need this slash, I need a comma. So it's looking at two values. Okay, we're back. So our geometry is back in here. So we don't have any errors left. So we have our textual fetch, animation point data, and let's see. We need this point data exported to the pixel stage. And if you scroll down here, you see that Touchdesigner already flows the point position data through the vertex stage by declaring, let's see if I can find it, world space position P. So if we're going to override this P value, let's see, it's a vec3 P is anim point data. So you're basically going to override the P function up here and connect this variable to the P. Close it. Well, you see that it's working. Our geometry is moving and we still maintain a 60 FPS, so that's a relief. So we have instance our geometry and it's playing back based on this LFO. So if I crank up the frequency, it's going to move a bit faster. There's some kind of hiccup in here that might have something to do with the range. Let's see. I use 34 if I fill in 1. Yeah, that looks a bit smoother. Okay. But this is a bit boring. And like we've mentioned in the tutorial description and in the introduction, is that we're going to offset the playback. So again, think about this flipbook. Like the instance number 1 is going to start somewhere in the middle of the flipbook and the other one is somewhere on the end. So we basically need some kind of incrementing value which starts at different positions. And there is a neat trick for that, so we can use a noise. So you're basically generating different points in a random way, and that stands for the different position inside the flipbook. So first of all, this noise needs to be just as long as the amount of instances. So channel, these are 20 instances. Set this one to samples. So pattern length op pattern 1 dot par dot length 20, but it starts here at 0, so we have one more. Just put in a simple -1. So now we have just as much of instances as random points. For me, this is a bit too smooth, so I'm going to use a different type. So do random. Okay. I'm going to put in a math, because this randomization is moving between the -1 and the 1, and we need a different range because our animation is going from frame 1 to 34. So 1, 34, and we need this to increment, but it also has to start over. When it crosses 34, it has to start from 1 again. So what we can do is we can add another math, generate some kind of incrementing value. We can just use a simple function abs time.frame, combine jobs add. So you see that it's moving up, but it's far beyond 34. So we need to clamp it somehow. I can use a limit. If you set this one to loop, zero, 34, you see that it now, starting from 0 up until 34 in a randomized way. So this one is done. Close it. So now, instead of the playback, the shader has to look at this null 8. And just like we did with all the uniforms, if you would like to have something from the network into GLSL land, you need to declare a uniform. But these are basically much more values in one container. This is just one float. These are a lot more. So you can approach this as a list of numbers, a list of 20 numbers, 20 instances. So you can approach it as an array. So if you go to the Array tab, you also have a bunch of uniforms you can declare. So first, put a null 8 in here. Let's call this instance animation. Set this one to texture buffer. I'm not going to explain that. It's way too technical for this scope of. Just bear with me. Just put that one to texture buffer. It's basically the same thing as you did here with Textual Fetch, but it's in a different form. This is in a texture form, and this is in a chop form. And by looking at these, you can approach it as pixels or texels. You have to put that one to texture buffer, because we're going to use Textual Fetch again to look up these values. So we've already put it in here. Uniform. And this one is called a sampler buffer. And we've called it instance animation. So no errors. That's convenient. So this was sampler 3D. This one was sampler buffer. But the convenient thing is that we can use Textual Fetch here again. So let's see. I think we're just going to delete the playback, because offset is a good name for a variable. So Textual Fetch again, capital F. It's 2D, so we only need 3 values. First, we have to look at the sampler buffer itself. It was called instance animation. Instead of 3 values, we need 2. So an IVEC2. Let's see. I think I'm going to delete this IVEC2 because I'm not sure if we're actually going to need it with this 2D texture buffer. Remember that we have declared or showed this function called TD instance ID, which looks at the index of every instance, and that's exactly what we need. So we have the sampler buffer, instance animation. It's fetching the information from that buffer. It's called offset. So we might only need this instance ID. Fingers crossed. So we now have this error again, which we already had here. So I only need 1 value. So we probably can use point X. Lo and behold, we have our animation offset. So what we did, we used the instance ID. So this would be the first one, second, third, fourth, to look up its position here through the sampler 3D. So again, we have all our point displacements recorded into a texture. We have our X and Y, and then we have all our Z values. Remember that flipbook again. You have your frame, your different poses. Just approach every leave as one coordinate system, and the time, the moment of time in that animation is the Z value. And we randomize that, connected that with the instance ID, and now you basically have your animated offset. And you still maintain 60 FPS. And if you would try that in subspace, it's not going to happen. It's not going to work. Or you can copy every FBX multiple times. Eventually it's going to drop frames anyway, and this is way more convenient. It's a bit technical. It's probably a bit dull to set it up. But if you just set it up one time, you can use this one in any project you would like and use quite dense geometry and maintain a steady FPS. We can probably make this one a little bit less hard-coded. Let's see if I just crank this one up to 30. Yeah, you see that I just have to adjust the range, so I can, let's see, me.par.length. Yeah. This one is changing along. Let's see, also 30. So yeah, let's see how is it actually looking in the render. Rotate it. Quite fun, right? Let's see. Maybe move this one a little bit slower. Multiply it by 0.2. Nah, it's a bit too slow. Let's see, 0.8. So yeah, that's how you can offset an animated FBX, instance it, and offset the animation by using an Alembic format. Hopefully you've learned something. Please like and subscribe to stay up to date, and we'll catch up next time.